Okay, dear student, please see this small lecture video so that you can learn something before the examination and test yourself before the exam tests you. Today's topic is crystal field theory and some related question and answer that I have taught during the offline class. So next, let's see this. Uh, as we know, crystal field theory means after the valence bond theory, and we have this theory. The main postulate of the theory I have given during the class lecture. So remember that thing. Here I mentioned some short idea so that you can learn easily. Here, the relation between ligand and the central atom, as you know, the bond between the central atom M and ligand is coordinate bond. Uh, the donor is ligand and acceptor is central atom. And then we have learned that. Here, the spectrochemical series show the relative ability of some common ligand to split d orbital. Means splitting. Crystal field theory reflect the splitting of d orbital. How the d orbital gets split, I will explain here also. Here, strong field ligand and weak field ligand. In this series, in between these series, we can arrange, we can put some other ligand also. This is some idea. Which one? This one Cn negative is strong ligand and I negative is weak ligand. Then D level splitting means the gap between the two energy level. In D level, we have double doubly fold double degenerate and triple degenerate. Mean doubly degenerate orbital and triply degenerate orbital. I will show the figure also in this after this in the next slide. Means D level split larger and D level split smaller. Ligand that produce large energy separation between the two energy gap called strong field ligand, and those produce small separation are called weak field ligand. And this is the three-dimensional view of the tetrahedral and octahedral. This one is octahedral, and this one tetrahedral. And the axis dotted line represent the three axes X, Y, Z here also. But the orientation of this triple tetrahedral and octahedral is different. Here, this is the 5D orbital, D1, D2, D3, D4, D5 like that, but we put the name DXY, DXZ, DXY, DYZ, DXZ, and the DX square, Y square, and the DZ square like this. This is another set, and this is another set, and this is another set, and this is another set. In this figure, this is tetrahedral and this is octahedral. Here, triply means we can also call three-folded and two-folded, three-folded and two-folded. Why the two-folded goes up and here two-folded goes down in tetrahedral, and the three-folded goes down from this original, and the three-folded goes up from this original. I will give the explanation here also. The orientation in tetrahedral and orientation in this octahedral is different. So the orbital, this is the dark portion, dark spot represent the ligand in case of tetrahedral, and this ligand and approaching are not in the same line, that is deviated. But in this case, approaching ligand and the axis are in the same. So the energy of this double folded align with the approaching ligand. That is why repulsion more. That means energy is higher. That is why to stable the higher energy, it goes up to the higher level from the original, and three-folded goes down because it is slightly deviated from the orientation. This here in this case. This one, as you know, double folded on the axis and a triple folded between the axis. That is why Due to that orientation, the approaching ligand and the depth of the orbital are in align in case of octahedral, align with the double bonded. In tetrahedral, align with the somewhat closer to the tetrahedral, directly aligned somewhat closer to the three-folded with that of tetrahedral geometry. This is why it goes up due to the higher energy, means more repulsion here, less repulsion here. So this is why the conversion that reverse is. So this is ground state and this is excited state after splitting after the gap, and this is ground state tetrahedral, this is excited state different. So the energy gap, the gap between these two and these two is called energy gap that I have mentioned in the previous slide. So come to the this one. Let us take one common example. For example, this one, iron hexa aqua iron 2 and hexa cyano iron 2. Here, this charge is not related to this iron, but here this charge is directly related to this iron because this is neutral. But in this case, indirectly related to this iron, means here negative, it carry -1, then here 6, 1 -1 into 6, we have 6 negative, and after neutralizing with this we get 2 positive, means here also same oxidation state of iron. Here also iron show the +2 oxidation here also +2 oxidation here, means 6 - 4 we have +2 here. This is 6, means due to 0 value it is neutralized, means only this positive directly related to this means oxidation state. So +2 means loss of 2 electron. Means in case of iron, as we know, in the electronic configuration in the ground state, as I have just remember this, I am saying argon, then 4s2 3d6. Then after losing the electron from 4s2, we have 3d6. This is the electron of the 3d6, means iron 2 show 3d6, means d6 configuration. So the electron 6 is distributed here like this: 1 2 3 4 5, and the last one interlies in opposite spin according to Hund's rule. Then this is high spin complex and low spin complex. How this series and this water and CN is different in the stream. Just back to the series. This one is water and CN is here. Means strong CN is stronger than water. That is why CN in CN ligand, the gap between the doubly folded and the triply folded is what? Large, means large separation. This compared to water. So this is why. In this case, the gap between the double folded means doubly degenerate orbital and triply degenerate orbital in another name is very large. In this case, very small due to the different strength of the ligand. That is water and the CN are different ligand having more powerful, more stronger. This one is why. This energy is denoted by Eg and this is denoted by T2G. G means Garrett, means for the center of symmetric, means center of symmetry possessed in the octahedral, but in case of tetrahedral, no center of symmetry. So that is why it show the electronic configuration is different. These 6 electron distributed like this: 1 2 3 4 5 and 6 like this. Repeat. Just see the 6 electron distributed like this: 1 2 3 4 5, and the last one is 6. So this is the model of electronic configuration in the small gap, and in the large gap electron enter like this: 1 2 3 4 5 6 like this. Means the 4 electron cannot goes to the higher energy level. This is due to gap, more gap. Just like in our everyday life, just same for the same family. Suppose that family goes very far, we cannot contact easily. That is why in our Manipuri, just sense Yunthang Naragasu Sagai Manor, Daragadi at Misang Lanai, the Sagai Manaragazu Yunthang Natabayam Lapto Kitaragati, when Misang Lana Payatapan Mina, do you keep to niche the lady? The electrons mana, I gave a winner as I give 4 electron. The 1, 2, 3, 4, 5, 1, 2, 3, 4, and counting the but in the actual configuration, this see it's 1, 2, 3, 4, 5, 6. But here 1, 2, 3, 4, 5, 6. And configuration 1, 2, 3, 4, 5, 6. That's counting. But this obey the another sequence of electronic configuration. This is another sequence of electronic configuration. There is no increase or decrease in the electron, but the distribution of electron is different. Here all the 6 electron get pair. Here all the 6 electron are not here. Only 1 pair we have. So this one show another magnetic properties, and this one show another magnetic properties. As we know, those having any species, compound, molecule, or any big or small having unpaired electron is paramagnetic. Having no unpaired means all the electron get pair means diamagnetic. This compound is diamagnetic and this compound is paramagnetic. When about the diamagnetic and the paramagnetic question may be put, so remember this. Electron will fill the lower energy orbital first, like this. I have mentioned this is another part. So come to the next. Now let us consider some questions just to remember the theory we have learned, valence bond theory we have learned. Here explain on the basis of valence bond theory that nickel tetraamine complex mean tetraamine nickel 2 complex ion is quad planar structure and diamagnetic, and this one ion is tetrahedral and geometry is paramagnetic. The geometry is also different. This one is quad planar and this one tetrahedral, and nickel 2 here also nickel 2. This nickel 2 and this nickel 2 is different in this one is negative and this one is also negative, but the ligand is Cn, Cl chloride here or Cn. This ligand is strong than this. Means from the chemical series, that's remember this chloride means Cl negative is weaker ligand compared to Cn cyanide ligand. So due to that, the geometry and other properties will give different. Let's see the answer. Nickel is in the oxidation state 2, means after losing the 4s electron, we had 3d8. This is the d8 configuration. D8 configuration. In the 5 pocket, high 5 orbital, suborbital, 1, 2, 3, 4, 5, 6, 7, 8 here. This one, the back end. This nickel will give vacant orbital as mentioned in the theory, will give vacant, or how many vacant orbital? 4. Here the number of ligand is 4. Here also number of ligand 4. Just in Quina, mi mari ladi pida thaba soki mari thaba pamba mari piba no man pido, as I mentioned in the class. And this is ma pido. Here there are 4 CN ligand, thus it can either have tetrahedral geometry or square planar. I khangdri mina sina mana proof torakanda khangappu question ni khangdri da square tetrahedral or bi square planar or bi. Since is a strong field ligand, it goes pairing of unpaired electron. Manga sagi sigi mapang CN ligand si mapangan kan banina CN ligand sina nickel sida mana thai by nickel just you have 2 unpaired electron, please get in paired state the tamu aina mana na adu tai man pami si pambai man di ma si mapangan kan banina sigi mana si da tongan chai rag lei bi tawningdaba sigi posi pairing tahandore adutadi here 8 electron also here 8 electron this masigi orbital is man loba pamagin man loba pamisi kaino this is strong mapangan kalle force kan bani mapangan shakti kan bani na hangba mana magi sida koi isai chaira leibidongna leibi pairing ta chalo stable loina ba haina just adugi portu ni mana sida harisi pairing toksale adu sida adutadi si hang aduta ma lodoi 1 2 3 4 man lodoi adutadi d1 means d1 ida suare s p2 1 2 3 4 si box mana kop toksalane sigi sit orbital home je si hybridized tawrane d1 s and the p2 hybrid we have 1 plus 2 it is 4 orbital to get the 4 lone pair electron donated from cn ligand mari di ma laktoine and sida haidiba posila mina kaidore sigi dsp2 haidiba hybridization this square p square adi mangi koina khangiba square se ko koi square mana koi ge square koina khangba square to ko sida p de khangani na chi square ni maya ida ma ji nickel ji phamaga square gi corner mari da square gi square gi corner mari da na ji akoi gi square gi corner mari da ma ji phammani square je koi gi hana square la aga mayai da mana phammaga corner mari da chain ligand je chai tho lairani sigi geometry do sina amma bara mana ko sigi sida square phammaga nickel si mayai da phammaga corner mari da chain ligand chai tho ne mana si lawra posigini d ama man sinarapagi d ama s ama p ani sinabagi magi geometry si magi square planar type sida square ma ngasai ma haise ma sida si pose square planar oi si pot magi ligan mapangan kan basinane then mana sigi posis da hairetu but they unpair am ta laitre it undergo dsp2 hybridization that means square planar ulle and since all the electron are pair they are oi gre unpair laitre it is diamagnetic. That in this case, nickel chlorine is the muyengazi tetrachloro nickel 2 ion is the muyengazi masi weak Cl negative si weak field ligand. Adu tadi weak field na masigi electron mana disturb to bungam de. Mas dadi mapanggan bena sigi electron mana disturb to biya. Pia toksalune yeng bu nungai hai bugum. Sidadi mana hai bungam de. Hai bungam de mina mana kadare sigi orbital sina sine moy humje. AsP3 S ama P ahumuk simala sp3 overtime hybridized tawragadi kai tai tetrahedral type sidana square planar type adu tadi magi geometry se kai tawra tetrahedral oirane sidana magi geometry magi d location mangam da adu da sida magi electron de disturb to bangamdre adi pairing pisan bangamdre mapangan solamrina magi adam as it is laisare magi kasagi does not cause pairing due to the weak field nature of the CN negative core. That is why the presence of unpaired or electrons in a magic paramagnetic pull. Then come to the China Togna, she does who she does the practice of the later and a sigi sika dore sina paramagnetic sina diamagnetic mataki duga saman edu sigi paramagnetic or bigi laser sigi co si mapangan kan bani CN gi sagai na tai tona mas mapang kan bani na mana kadore diamagnetic oigani degi magi geometry da su kadone ba do both are tetrahedral sidadi kadore tetrahedral ngakta oiba ado manga sagi kenari sigi posida sidadi sidasu tetrahedral ina sigi sp3 loina mak se sinarani sidasu adogi potun adana kenna doisi kaino sidasi is all is strong therefore it goes pairing up 3 unpaired electron and 3 the ladies the unpaired electron also cause for s electron to shift to 3d orbital and therefore thereby giving rise sp3 sigi electron is on the putchen do sigi electron je come to late thangsen do ne ma sidadi nickel si neutral the lay. Sidana nickel si positive state the lay. Sidana neutral and 4s electrons mang the 4s electrons the kamaito mang and do the sigi electron sida amamam lay yen handore dan the loine to amamam yeladi sigi sida pr tasalani sida pr tarani adda di kadore and pr amata lay roy aduna diamagnetic orani sp3 hybridized torane sidadi sigi electron ju uri ado magi co sina maram moiraga sigi electron sida kausan darane sida pairing tawrane masida se pairing tawraga koi kadara sida chongchanni haise they are by giving rise sp3 sigi sp3 aduna by geometry se manari ne ai tawdana another ko this one is strongly paramagnetic whereas this one is weakly paramagnetic manga sagi mana mapangan kanba sida siloi la leire demai si ligan mana the be malam dire charge iron also plus 3 state iron also plus 3 state mean mag configuration is d5 ni in both the cases d5 to si later and sida cn strong filina magi fine later baji subaina ma sigi d2 ji low na bo na re mai geometry je magi kano lakada mina sp3 id d2sp3 hybridized tawdini d2sp3 hybridized tawdini ana sigi d2sp3 sidana sp3 d2 hybridized tawdini weak pair tawdina ana sida khenari sida di kaidano unpair ama khatang ulle sida di unpair electron je manga mak akoi sigi manga mak si leidin sigi case maram di strong pelini sidana kaino sigi hybridization sigi d2 maga S ki amaduga P hum amaga sinarane aduna sida laidoise kano D2sp3 sidana weak pin warabina sigi si hangba yaro sumai lerani aduna sida laktoiba S P D dagi sigi D sina 4 ni 3D ni somda 4D harga 4S 4P 4D na lakadai 4D ki orbital to sinarane basida 3D orbital scenario 3D orbital scenario maram di sima pangan swan minina disturb to bungam de ado CND mangam disturb to raga si manungi kasai mathaki duga hape nickel gi CN ni gal duga hape chamane ana dumana knowledge to low nam if you have any confusion you can ask adu tadi here sida leijeng here only sida unpair ama khaktang lera mina magi geometry 1 plus ko 1 adu ta 3 Robert 3 1.7 ball magneton magi magnetic moment ki value je ko so here on the other hand weak field therefore it cannot cause pairing haji pairing sidadi pairing to holle electron manga loina mak unpaired layer adu busigi mapangan si kan banina pairing to biya bagi to solo har kana amal lam ho bududi ma pairing to ya da na single dum lai sare masigi electron sina paramagnetic ulle magi mapangan si magi calculated akoi gi formula sina tae 1.732 magneton tare but on the other hand kadara mapangan son binina pairing to dre it mean number of unpaired dum 5 adum lai de 5 lai adu tadi magi kaino root over 35 si bore magneton 6 tare adu tadi this one is kadara strongly paramagnetic one is strongly paramagnetic ko aina sida strongly is ipachitharam mean this one is weakly paramagnetic compared to this because here only one unpaired electron here all the 5 unpaired electron present the only magi hybridization sigi case sidana listen carefully d2sp3 hybridized tawi sidana sp3d2 mean d ani s ama p ahum sidaju d ani s ama p amu sigi d sina manungi d n-1 ga haigi badu sidana nd ko adana sina kaida outer orbital complex inner orbital complex ko this one is inner orbital complex and outer orbital complex but the mode of hybridization is d2sp3 sp3d2 I repeat here d2sp3 that is why d na halamina inner orbital complex here sp3d2 d na kolamina outer orbital complex but both hybridization d2sp3 or sp3d2 give the same geometry octahedral there is no change in geometry but in case of tetrahedral ga square ga di my geometry keniko aduna sigi post ini. Then another just explain this one is inner orbital complex and where is this one outer orbital mang sagi si lei si khango ri mathaki duda mathaki part to da matiang oina da sigi to sigi 1 2 sigi d ani si deina 1 2 3 4 5 6 sigi campus ya ligan gi phambam oi doine ado sidadi kai dora si pairing ama khak si tor ma si disturb tor si low ya si low su pha roi di tu pha da mina si dum thambi re si loina si deni si bok si low re 1 2 3 4 5 6 ado da si dana kaino mapan gi di si dana manung gi di. This why inner orbital complex and outer orbital complex, and see the clip you can learn something. I told na mathang amu la ji I told na predict the number of unpaired electron ji sida unpaired electron to toy sida nickel is in platinum is in +2 oxidation state. It means my hybrid si mapangan kan banina sigi di masina rani sigi di dagi electron som chongalami sigi di sinaraga sigi d1 jiga magi orbital mari laigedoi ni cn mari ni na andana ngasagi dsp2 hybridization tawrani ko editadi mai geometry si kaidora square planar su tarani mase square planar gi malam do koi khange aduga sida sigi electron sida chongjen gi targa di kaidora sida di unpaired ui chongjen gi targa di magi unpaired do pair tagra adudadi ma chonghali si kaigino si mapangan kan bagina adudadi manga sagi pairing thohale it cause the pairing of unpaired electron pairing thole pairing laitre adudadi hence there is no unpaired electron the number of unpaired zero tare ai tawna sigi in the hexa aqua amine to contain ion contain 5 unpaired electron while the this contain only this one manganese +2 here also manganese +2 means here 6 minus 4 +2 here direct +2 because it is neutral. This +2 oxidation step +2 oxidation electronic can be d5 and d5. The crystal field see the water is weak, see the cn is strong. This is why my electronic configuration ngasagi energy level da T2G EG mana lagi tu T2G da electron ahum mama adagi EG da electron sigi last ki 3 se mana 3 and 2 sigi ngasagi sigi posi kalno split to horakanda ground level da lehba T2G do see this T2G mean triply folded the electron ahum mama doubly folded the electron ahum mama maram di mai energy do gap lai doina ado in this case sidadi kadara T2G ti asobo masa we no problem pa T2G the electron manga mak sangre kaigino da ngasai energy gap do doubly folded ga triple gap lai here also 3 + 2 here so direct 5 ado tadi in this case hexa echo sidadi has 5 unpaired electrons sidadi the 3 ma 2 ma loina unpair loi leire sidadi kaidora amaka this only one ditadi kaidora adugi port ni manga se 5 unpair electron then only one unpair electron ko mai tawdna sigi idea chingji khangna bonoro. Thank you my dear student, and if you have any confusion you can ask.